All right, so here's a slightly more complicated example where we have the input, or where we're inputting an inverse trig function into one of our original trig functions. So again, with anything anything like this, we can always start on the inside of the parentheses, since order of operations dictates that that has to come first regardless. So here I'm going to have arc cosine, which I'm going to go ahead and rewrite it. I'm just going to write cosine to the -1. Again, that's inverse. Two ways of writing the same thing. And here we have of x plus 2. Okay. Well, I know that this is really the same thing as saying cosine of some angle theta, and that's what I'm looking for, is theta. Okay, so basically saying that this is equal to theta. Okay. Cosine of theta, is equal to x plus 2, and I'm going to write x plus 2 over 1. Now for a second, you can pause it if you need to, try to think of why I wrote that over 1. Okay. Hopefully, you came to the conclusion that the reason I wrote that over 1 is because I know cosine is always equal to adjacent over hypotenuse. So now I have two sides of my triangle. I can always find the third. Okay? And if I rewrite my equation over here, well, since I went ahead and I set arc cosine equal to theta, really what I'm trying to find is I'm saying sine of theta is equal to opposite over hypotenuse. So as you can see here, I'm simply setting it up to where both of these are referencing the same triangle. And since I have two sides of the triangle, I can find the opposite side, and I'll be able to figure out the ratio for sine. So looking at this, what I'm going to do is go ahead and, hopefully you guessed it, draw the triangle. Okay. So I'm drawing out my triangle here. I call this theta. Now I have the opposite side. I don't know. So I'm going to go ahead and call that y. And the opposite side is generally referred to as y. Okay. And then I have that the adjacent side is x plus 2, and the hypotenuse is just 1. Okay. Now if I want to find y, I can use the Pythagorean theorem, and I can say that x plus 2 squared, okay, plus y is equal to 1 squared. Okay, and then I go through and I get that, y squared. So x plus 2 squared plus y squared is equal to the hypotenuse squared. Okay. So then I can subtract x plus 2 squared from both sides. Okay. And you wind up getting y squared is equal to 1 minus x squared plus 4x plus 4. I just expanded that out. Now you have to remember to distribute that negative all the way through, but you should end up getting, let me move this up a little bit, you should end up getting that y squared is equal to, let me see here, negative x squared minus 4x minus, plus, minus. That's what happens when you try to do things in your head. I recommend against it. Negative x squared minus 4x minus 3. Okay. Now, to finish this one up, what we're going to go ahead and do is we're going to go ahead and take the square root of both sides. Okay, and so we get that y squared is equal to that y is equal to the square root of negative x squared minus 4x minus 3. Okay. So I now know that y, or in other words, my opposite side is equal to this. So again, this was the opposite side. I have the hypotenuse there, and I can simply plug it in. Well, since I see that my hypotenuse is just 1, I can see that sine is in fact just going to equal what it equals right down here. Okay? The square root of negative x squared minus 4x minus 3. Okay, and that would be all over 1, but again, we don't need to put that, and there is our final answer. Okay? So again, the key to these is to realize that first off, you're moving from the inside out, and then to realize that any time that we have the arc cosine, we are inputting a ratio into that. So that we automatically, if we know that we have a ratio of x plus 2, when we're dealing with the inverse of cosine, that we're going to have our adjacent side and our hypotenuse, meaning that we can find the third side using the Pythagorean theorem, and that will allow us to find any other trig values that we need to find.